welcome to ESE Engineering Academy. Today you have to see the preparation strategy of very big subject of mechanical engineering as well as production and industrial engineering. And that subject is production. We also say as it is manufacturing subject. And this preparation strategy you have to see for GATE 2024 exam for both branches, that is ME as well as PI. ME as well as PI. Now guys, just I want to give my introduction. I am Ravi Doifode, faculty of production subject in ESE Engineering Academy. I completed my MTech from manufacturing and automation, and I am teaching the same subject in ESE Engineering Institute. Now in this subject, in this session, you have to see the preparation strategy for the GATE exam, that is the Graduate Aptitude Test in Engineering, as well as I will tell you the preparation strategy for some other exam also, little bit for other exam, such as Engineering Services exam, SSCJ exam, state level exam. I will speak on that also, but little bit. But the more focus, more than 90% focus will be on GATE exam only. Okay. Now see guys, this is the first we have to discuss about the GATE mechanical engineering exam. The students fill the form and now the exam is very near. Hardly 3 months are remaining for the exam. And the many students who fill the form from GATE mechanical, they also given a second option as production and industrial engineering, and some student is given the option, second option as engineering science. Means the mechanical student can give the GATE exam from mechanical as a first option and PI or XE as a second option, either PI or either XE. That today I am going to speak for the mechanical as well as for the PI. Okay, now see, this is the GATE mechanical engineering, GATE production and industrial engineering, and you can see the GATE engineering science. Guys, GATE 24 exam is conducted by ISE Bangalore. You know already the ISE Bangalore is conducting this exam. And the total 7 IITs, old IITs as well as ISE Bangalore is conducting GATE exam, you know already. Then GATE 24 exam is conducted by ISE Bangalore, and according to that only we have to discuss what the ISE Bangalore like and what the type of questions they can ask and how to prepare for this exam. Now firstly, before starting the actual my subject, just see once the weightage of different subject for GATE mechanical, for GATE ME paper. The general aptitude you can see it is for 15 marks, mathematics 12 to 15 marks. This production my subject 14 to 16 mark, that is the highest weightage subject. Even though I am writing 14 marks here, but in the most of the exams they asked for the 16 marks. And then the thermal, that is thermodynamics and other subject, thermal related subject, heat related subject, you can see the weightage 10 to 12 marks. Then theory of machine, fluid mechanics, you can see all the weightage here, strength of material, heat transfer, industrial engineering, machine design, engineering mechanics and material science, all subject weightage, you can see it here. Now which material is best for preparation? You are already preparing for the GATE exam and the time is very less, not a 3 month also. Hence I want to tell you that the classroom notes are one of the best material for your preparation, the classroom notes. Whatever we taught in the class, not for production subject, for all subject, that notes are very important. And you can go with the classroom practice question, you can solve. Previous GATE questions are very important. Some students are asking, sir, is PI questions, PI previous year GATE questions is important for mechanical? Yes, definitely. And mechanical previous year GATE question is also important for the PI student. Then for this subject, you can prepare the both questions, the mechanical as well as PI question for this exam. Then ACE practice questions, we given the number of books, the number of practice questions are available with you. You have to solve that all the question, and if you are going to stuck somewhere, if you are not getting some concept, then already you can ask me that all different type of questions, any doubt, any query you can ask me. And this is most important, guys, in this lecture, which is the most important point in that preparation strategy. You can see this is the most important in the preparation strategy, guys, is online test series. Now from the today only, after listening my lecture, you need to schedule your study according to online test series. ESE online test series is one of the best test series. After this session, you need to sit there, give some subject-wise test. Then you can go with the full test in the January month. But now start the test series. This is very important preparation strategy. Just see, if you are studying according to the test series, then you have some aim, and according to aim you can study. You will study. And then if you are doing some mistake, or if you are unable to perform well, then what are the problems? Why you are not able to perform well, or you are not able to take the good marks in that test series? Now you will start thinking on that, and this will help you in final gate exam. And in the January month, give the full test series, 100-mark test series, and according to that test series, you can get the marks in the final exam also. Then the test series is very important. Start a test series from tomorrow. You have the 2 months. Start with the subject test series. Don't waste your time. This is very, very important. Some students, what they are doing, just last week I completed one batch here. Now what they are doing, they are studying very well, but no one is going for test series. You must appear for test series. This is very, very important preparation strategy here. And guys, here I saw that some students are there also online. Then you can also ask query here also. At the end of session, I will read your question and I will respond you. Okay? Yes. Now the weightage of production subject for mechanical, it is around 16 marks, and for the PI paper it is around 28 marks. For PI paper, you can see that the weightage is very good, and if you are good in this production subject, manufacturing subject, then definitely you will give the great performance in the both paper, ME as well as PI. Then start focus with the production subject and start the online test series with the production subject if possible. Yes, now you can see the total 9 chapters are here, guys. And out of that 9 chapter, the preparation strategy I am going to tell for metal casting first, welding second. After welding, I am going with NC machines, that is numerical control machines, or also we are saying this chapter as AMM chapter, advanced machining method chapter, in which we are teaching the NC machines as well as CNC machines with very important new topics, additive manufacturing. And then the NTM I am going to discuss non-traditional machining methods. Okay guys, this additive manufacturing, this topic is very important to discuss today because it is added in the syllabus of GATE 2021 for both branch mechanical and production. And in the, again, new topic is added in the metrology, that is the coordinate measuring machine. And for the GATE mechanical 2023, they asked 2-mark question on additive manufacturing and the 2-mark question on the coordinate measuring machine, that is 2-mark numerical they asked. And that's why the other topic got somewhat less weightage, because additive manufacturing 2-mark weightage and coordinate measuring machine numerical is for 2 marks. Okay? Yes, now these all topics, metal casting, welding, this is AMM, additive manufacturing, and non-traditional machining methods I am going to discuss. Yes, these all topics, first, second, third, fourth, fifth. Now see the metal casting, firstly see the syllabus comparison between the mechanical engineering and production and industrial engineering. Just see the different type of casting, design of pattern, mold and course, solidification and cooling, riser and gating design. Just see only the 3-line syllabus is given by IIT for gate mechanical engineering, but the syllabus is very big. The syllabus is not small. And the descriptive syllabus is given for the PI branch. You can see the types of casting process and applications, sand casting, pattern type, material and allowances, molds and core material, making and testing, design of gating system and riser, very important, design of gating system and riser. Just see here the design of gating system and riser, you can see for the mechanical also the given and for the PI is also given. Casting technique of cast iron, steels and non-ferrous metals and alloys, analysis of solidification and microstructure development. Yes, this is the solidification is also important. Other casting technique, pressure die casting, centrifugal casting, investment casting, that is the shell mold casting, casting defect and their inspection by non-destructive testing. This is the syllabus of PI. Guys, you can see that the mechanical has less syllabus, the PI has more syllabus, but both syllabus are same. Yes, even though it is written hardly 3 lines and here the number of lines, but the syllabus is same for both branch. Now, how to prepare this metal casting chapter, guys? How to prepare? Now, see, first, the theory is important. They can ask one theory question here. One theory question they can ask here. Hence, the theory is important and theory is not that difficult. The theory of casting chapter is very easy. Or also, instead of 1 mark theory question, they can ask the 1 mark numerical they can ask, or 2 mark numerical also they can ask. 1 mark theory or 1 mark numerical or 2 mark numerical they can ask for the exam. For which paper? For ME paper. For the PI paper, they can ask the theory as well as numerical, because for PI paper, the weightage of casting chapter is 3 to 4 marks, and for the gate mechanical paper, it is only 1 to 2 marks. Then how to prepare this topic, guys? The theory is important, which can give you the 1 mark. Whatever I given in notes that you have to read carefully, but don't go in deep manner. What some students are doing, they are taking one topic and they are start think on the topic and they are wasting the several hours. Don't become a scientist because it will waste your time. Don't go in deep in the theory, because we covered the theory, I covered the theory in such a manner that this theory is not important for GATE. This is important for GATE exam, ESE exam, SSCJ, railway exam, TSPSC, any state level exam. TSPSC is Telangana state exam. But not only Telangana, in all state exam in India, this theory is important. And I taught in depth. Hence, that depth is sufficient for your exam. If you are stuck somewhere in one point, then you can suddenly ask me the question. Don't waste time more on that. What happened on the one question, one theory concept, the student is going to think for 2 to 3 days. Then, and if he is asking the question, one question for 2, 3, 4 days, then I got that. It is very difficult for student to clear the GATE exam, because on small query he is going to waste the number of days. It must not happen. The time is very less. Okay? Or some student, what they started doing, they are taking some reference books, or from somewhere they are taking the notes, or they are going on the Google and searching the document, but production is not that easy. The content is not available in market. It is not that easy. And just for one concept, they are wasting their time, more time, just wasting their time. It must not happen. You ask me the question, I will solve your query and go for the next point. Don't waste don't stuck on one point which can waste you the several hours. Understood? It is very important. And what about the numerical? How to prepare the numerical? Guys, just see hardly 4 to 5 formulas are there. Okay, one formula is for permeability number. We have to calculate the permeability number, and that formula is VH by PAT. VH by PAT, this is the formula for permeability number. the second formula, you can see the second formula, you can see the important, that is the powering time. That is the powering time. Powering time is what? It is the volume divided by flow rate. What is the flow rate, guys? Flow rate is area into velocity. Now the question, this volume is whose volume? This is the volume of casted component, and that volume of casted component, they are always giving in the numerical, or also sometime instead of volume of casting, they are saying that the volume of mold or volume of casting cavity, then this is the volume. Then guys, this is the second formula, you need to remember that. Third is very important formula for the solidification time. The solidification time we have to calculate, that is denoted by tau. We know that the tau is directly proportional to the m raised to n. Then we are writing here tau is equal to K1 into m raised to n. What is the value of n? Always blindly we are taking the n is equal to 2. But it is not 100% true. The value of n may be 1.5 to 2. N may be 1.5 to 2, but whatever numerical we are solving, we are taking 2. But you need to remember that value may be anyone from 1.5 to 2. If they not mention anything directly, you can take the 2 and you can solve the question. And these all formulae, guys, you will get in the test series also, and which will give you a very good practice. And these only the important formulas. And fourth one is, one numerical is available on the centrifugal casting. That formula is also important. Some procedure is there, that's why I am not going to write that procedure, but that technique I given you very nicely, that you can revise. Then guys, you need to revise that all formulas, classroom practice questions, then all previous year GATE questions, and if the time permits, then some practice question. We are giving some books, from that book you can study that questions. And it's very, very important, start the test series, which can give you a very good experience, and these all formulas will be available in test series. How easy? Casting theory is very, very simple, and here you can see that in that all formula only, hardly total 5 to 6 formulas are available in the casting chapter, and on that 1 mark or 2 mark numerical will be there in the mechanical engineering paper. And for the PI guys, the question on this formula is compulsory. Compulsory, you have 1 question for 2 mark in the GATE PI paper. Okay? Now again, if you have any query, then you can ask me here in the live session. Now what you understood about the casting? The theory is very simple. Just read all theory, then solve all numericals. If you stuck somewhere in the theory, you can ask me the question, but don't waste 3, 4, 5 hours, 1 day, 2 days on one simple theory topic. Don't try to enter into that research. That is very important for your preparation. Okay. Now this was related to the metal casting, and now we have to shift for here the welding chapter. Guys, on the casting I said that 1 mark theory question or 1 mark numerical, or they can ask the 2 mark numerical also. And in the one exam, get 22, some multiple select question, means multiple select numerical also they asked for casting chapter. Now see, this is the welding. In that welding, guys, for the mechanical compulsory there is numerical. They are asking the numerical 1 mark or 2 mark numerical, and you know that the welding numericals are very, very tough. It is not easy to solve, but I given an excellent procedure, and by that excellent procedure you can solve 1 numerical, 1 2 mark numerical hardly in 20, 30, 40, 50 seconds. That excellent procedure I given to you, and you can solve any welding numerical by using that procedure. Okay. Now see the syllabus of welding here, the principles of welding, brazing, soldering, and adhesive bonding. You can ask me, sir, what about the adhesive bonding? That adhesive bonding is very simple thing. you know the plywood. One wooden sheet take, spray the gum on that, then stick the second wooden sheet. Then again spray the gum on that, then use next wood sheet, and in that way you can make the plywood. Then adhesive bonding is very small topic, and it is example is the plywood is the example. Now the principles of welding, brazing, soldering and adhesive bonding finished. What is syllabus? Nothing, but it is not true. The syllabus is, you can see the very big syllabus, and here in the PI paper they mention that big syllabus. Classification of joining process, principle of fusion welding process. Guys, which are the fusion welding process? In which the parent material is going to melt, that is known as fusion welding process. Means definition we are telling, by melting the parent material, if the joint is produced, then it is called as fusion welding. Then how many fusion welding? Here you can see that the flame. Tell me in which method the flame is going to produce. The flame is going to produce in the gas welding. Hence in the syllabus, guys, the gas welding is there, and gas welding is also one of the fusion welding process. Next is arc welding. Very big topic, very big topic, but here only one word arc you can see, but here there is no arc word also. But for mechanical, they are always going to ask the arc welding question. The next is resistance welding. What is here? Laser. That is the laser welding, but the topic we are going to cover in non-traditional machining method chapter. And here the electron beam also. This is the electron beam welding, and that topic also we are going to discuss in the non-traditional machining method. These two topics, laser beam welding and electron beam welding. Then heat transfer and associated losses. Oh, that is very important, this word. Heat transfer means there is a number of numericals are available on heat transfer. And how to prepare that numerical I am going to tell here. And associated losses. Some losses are there, that losses also we have to discuss in the today's lecture. Next, arc welding process. Guys, in the arc welding process, some processes are there such as shielded metal arc welding, gas metal arc welding, then gas tungsten arc welding, then plasma arc welding, submerged arc welding process, principles of solid state welding process, friction welding, friction stir welding, ultrasonic welding and welding defects and inspection principle and adhesive joining, then brazing and soldering process. Guys, these all syllabus is for mechanical student also. But what happened for the production PI gate? There is a more weightage for this subject. That's why there is a more possibility to ask the theory question as well as numerical. Then for PI paper, this subject theory is important as well as numerical is also important. Now here, which is the most important topic and how to prepare that? Flame means, guys, it is a gas welding. In the gas welding, we are going to obtain the flame. In the gas welding, we are going to obtain the flame. And only one gas welding process is very important. And that gas welding is oxyacetylene gas welding. Till now in the GATE exam, the number of theory questions asked in ESE exam, all state level exam, the number of theory questions is asked on oxyacetylene gas welding. Then you need to prepare that. Only the theory is there, numericals are not there. Then you need to prepare that, you need to revise the theory of oxyacetylene gas welding. Okay, then this theory is very important. The next, the arc welding. Arc welding, guys, the theory and the more important are the numericals, guys. Fantastic numericals are available on arc welding, and on the resistance welding, the fantastic numericals are available. Yes, some concept now today we have to see how to solve that type of question, how to prepare that question. Then the laser beam welding, electron beam welding is also there. But in the laser and electron beam welding, we are using the procedure of resistance welding only. Why? That also I will tell you. These important topics are there. Again, you can see that the brazing soldering process means brazing, braze welding and soldering process are there, and that is also theoretical topic. Then flame welding is important, brazing and soldering processes are important, and the numericals of arc and resistance welding you have to prepare. Now one student is asking question here, sir, your class notes is sufficient for PI paper or not, sir? The class notes are very important, and that is sufficient for PI paper. And guys, also I given some extra notes also. Yes, if you are going with the PI paper, then some extra notes also I am giving for that. In that extra notes, you can see that the solid state welding process are covered. That all processes, friction welding, friction stir welding, ultrasonic welding, that all theory you need to revise before the PI paper. Okay, Sai? Yes, but with the class notes, what I am telling you, go with the test series. Class notes, previous year gate questions, classroom practice questions, some extra question, and test series is very important. In the test series, you can check your performance, how you can perform in the test series. But some student get some tension because they are not performing well in the test series. If you got the tension, then you can contact me. Okay, I will tell you what to do and what are your mistakes. I can check it. Okay. Now see guys, here the how to prepare that arc welding numerical and resistance welding numerical, I have to tell it there. For that one basic concept, I am going to tell it here. Just see this one electrode I am going to draw here. This is one of the electrode. This is the workpiece, you can observe it here. Now guys, when the arc is going to produce, then you know that the arc is going to produce between the tip of electrode and workpiece. Here you can see that the arc is going to produce. Means guys, in the simple arc welding, the arc is going to produce in the atmospheric condition. But in the TIG method, tungsten inert gas welding method, metal inert gas welding method, that is MIG method, we are using the inert gases, then that arc is going to develop in the inert gases. But either there is atmospheric air or the inert gases, here the arc is going to develop, and definitely there are some heat losses from that, and that heat losses are the radiation and convection heat losses are there. Radiations and convection. Radiation and convection heat losses are there. Very, very important this topic. Radiation and convection heat losses are there. And here in the syllabus you can see the point here, losses, heat transfer and associated losses. Now you can see there is some loss of heat in the radiation and convection. Then guys, whatever the energy we are going to supply here you can see that the power supply is here. Here you can see that the power supply is here. Whatever the power we are going to supply, that power is reaching here by maintaining the arc length, but some heat is going to lost because of radiations and convection, and some heat is going to reach here. But whatever the amount of heat is going to reach here, that heat is not used for melting purpose. Why that heat is not used for melting purpose? Because that heat is used for melting purpose, but all supplied heat is not used for melting purpose, because that material has some thermal conductivity, and because of that conductivity some heat losses are there, and that heat losses are known as conduction heat losses. That heat losses are known as conduction heat losses. Then that some heat is going to lose through that conduction. Hence, just consider the number. If we are supplying here the 100 power, then out of 80 is available here. Means here not 80, total 100 is available. But out of that total 100, just consider that in the convection and radiation, the losses are 20 and remaining is 80. And remaining 80 heat is supplied to that workpiece. but out of that remaining 80 also, just see that the 50 is only useful, 50 is only useful for melting purpose, and remaining is going to loss in the conduction. Then here you can calculate the difference. Here what the amount of heat is going to loss in the radiation and convection. Here you can see that the 20 heat is going to loss because of radiation and convection, and here the 30 heat is going to loss because of conduction. Hence, here we can see the first efficiency is the heat transfer efficiency. Here also you can see the heat transfer and associated losses in the arc welding, that heat transfer efficiency is equal to input by output. And we are telling this power is the first, this second, and finally used for melting is third. Then heat transfer efficiency I am showing by eta only, but some people are also can use the eta H, that is the heat transfer efficiency, and that is output by input. What is output here? 2, and what is input here? 1. The next efficiency is melting. For melting, what efficiency is used? Then you tell me what is the input for that. Input is second energy, means 80 is the input. First is the 100, second is the 50, and second is the 80, and third is the 50. Then here you can see that output divided by input, output is 3 and input is 2. And here the two type of efficiencies are going to occur. When you need to prepare these formulas, guys, this is the best preparation strategy to learn this concept and use these formulas. Directly they can ask the question on this formula. And in the previous year GATE exam also, directly they asked question. Don't use any other method. Don't see any method. Whatever I given in the notebook, whatever I mentioned in my notes, use that method. Simply in some seconds you can give the answer. Very simple questions they are going to ask on that formulas. And guys, this is related to arc welding formulas, but the same case we have to also see for the resistance welding. Now see the case of resistance welding, how that efficiencies formulas are asking for the resistance welding. Now see in the resistance welding, we are joining the sheets. We are joining the sheets. You can see that this is the sheet 1 and sheet 2. That sheets we are going to join in the resistance welding. To equal sheet also or unequal sheets also we can join in the resistance welding. Now here with the help of electrode we are giving very high force. With the help of electrode we are supplying very high force. We are giving with the help of electrode here. The electrodes are, guys, very big. Electrodes are very big here as compared to that sheets. And here we are applying the alternating cycles here. We are applying the power here, the AC cycles. AC cycles, this is the power is supplied, but AC cycle, most of the cases we are using the alternating cycles. But if the AC power is not available, then some welders are using DC also. Then guys, here what happen when the power supply is given, then small pool of molten metal is going to form here, and that small pool of molten metal is known as nugget. What is the meaning of word that nugget? It is the small pool of molten metal is known as nugget. Small pool of molten metal is known as nugget. And in that resistance welding, the nugget is going to form, guys. The nugget is going to form. Yes, one student is asking question. Ratna Tejas race online recorded class is sufficient? Yes, it is sufficient. But again I am telling, with my lectures, my notes, all previous year GATE questions, theory as well as numericals, test series, ESE online test series is very important for you. Yes. Guys, in the last cases, means in the arc welding case, this is also the same case for gas welding also, because from the flame also the radiation and convection heat losses are there. But here, this is the case of resistance welding. From that resistance welding, is the same type of convection and radiation heat losses are there? No. convection and radiation heat losses are not there, because inside the two plate or also we can use the sheets, because it has very small thickness. Guys, when the thickness is less than or equal to 5 millimeter, then we can saying as a sheet, or also we can also say thickness is less than or equal to 6 millimeter, then it is sheet. Either 5 millimeter or either 6 millimeter. No need to worry about that, it is not a big thing. But in the resistance welding, we are joining the sheets, or we can join the plate also. Okay, but mostly the resistance welding is used for joining sheets. Now see, heat is going to produce in the atmospheric condition. Here you can see that in the atmospheric condition, here the atmospheric air is there, or inert gases is there. The same case is not there for the resistance welding. It is going to happen the inside. And therefore guys, in the resistance welding, the melting efficiency I am saying as directly melting efficiency is there. This is the melting efficiency. Heat transfer efficiency is not there, because only one type of losses are there from the plate, and that losses are conduction heat losses are there. That losses are conduction. Then here I am saying that whatever the heat present here, available here, some heat is lost by the conduction and some remaining heat is used for melting purpose. Then this is the first is power supplied and second is heat used for melting purpose. Then melting efficiency is equal to output divided by input, that is I am writing the 2 divided by 1. In that way we can give the formula. Then guys, this is very important. These two formulas are very important, because in many exams they are going to ask question on these two formulas, okay. Yes, now how to prepare in that welding, these two topics are very important, and the guys numericals are available on these two topics only. That's why it is not that difficult. And what about the theory? You need to focus on flame, means oxyacetylene gas welding, and our topic soldering, brazing and braze welding, okay. This is about the welding. Now see the next topic, that is advanced machining methods, AMM. Now again see the mechanical syllabus, NC CNC machines, okay, CNC programming, okay, but very small programs are there. For the diploma student also very big programs. For engineering degree student also in their degree exam very big programs are there. But for GATE exam, very small 1, 2, 3 lines program is there. Not a big program is there for GATE exam. Next, basic concept of CAD/CAM and their integration tool. This is the ME syllabus. Now see the PI, CIM, Computer Integrated Manufacturing, that is the CIM, Computer Integrated Manufacturing. Basic concept of CAD and CAM, then geometric modeling, CNC, automation in manufacturing, industrial robot configuration. Now see this topic, industrial robots configuration, drives and control. There is very less possibility for mechanical to ask this question on the robotics, on the industrial robotics. And that topic, that subject, big subject is available for ESE exam. Okay, hence there is no possibility, not written in the syllabus also, but very less possibility to ask question on this topic. Next, the cellular manufacturing, flexible manufacturing system, that is FMS, group technology and computer aided process planning. Guys, what to prepare in this topic? What they can ask? 1 mark theory question, or 1 or 2 mark numerical they can ask. The theory question, not very big theory. The chapter is very small, but if they ask the question, then it can give the good benefit. Theory is very easy and numericals are very easy numerical. Just see one type of numerical here. I am going to tell you. Now here it is, the diagram you can see. One concept I am going to tell you, how to solve one type of question here. What is this TRS? What is the TRS in the NC machines? TRS is tape reader system. Then this is the machine. This is the CPU, central processing unit. Guys, we are giving the program to the CPU. We are giving the program in the millimeters. If you are telling this work table, here this is the work table, guys. Here this is the work table. If you are going to tell work table move in x-axis by 10 millimeter, then we are giving the 10 millimeter distance to the CPU. CPU converting this 10 millimeter distance into the number of pulses. It can convert into 400 pulses, 500 pulses, 400 pulses or 500 pulses. It is not fixed. 600 pulses, 700 pulses, it is not fixed. Very important topic. Number of questions are asked on this topic. And very easy, within some seconds you can solve this question. Now the 10 millimeter distance that CPU is converting into some pulses. That pulses are known as voltage pulses, or also we can say as electrical pulses. And that pulses is given to the motor. And here you can see that motor shaft is there. Motor shaft is there. This is the motor shaft, you can see. This is the motor shaft. Here this is the gearbox. This one is the lead screw. When that 10 millimeter distance is converted into 400, 500 pulses by CPU, that pulses is given to the motor. Then motor is taking that electrical pulses, because electricity is required to run that motor, guys. Then that it is taking that 400, 500 pulses and it is converting into mechanical energy. What is meant by mechanical energy? The motor shaft is going to rotate. And here you can see the gearbox, and through the gearbox the motor shaft connection is given to the lead screw, and that lead screw is also going to rotate. But here the one nut is available, or why we are using the lead screw? To convert the rotary motion into linear motion. Rotary motion means motor shaft is giving rotary motion, then motor shaft is connected to lead screw is also going to rotate. And with the help of nut, work table is moving linearly. Then when we have to run that work table by a distance of 10 millimeter, then CPU can give the 400, 500 pulses. Motor shaft is rotating, motor shaft is connected to the lead screw with the help of gearbox. That lead screw is also going to rotate, and with the help of nut, work table is going to move by a distance of 10 millimeter. Yes? That is the story here. But here, guys, do you know how many machines are, how many motors are available here? Guys, here is one spindle. How the spindle is rotating? This spindle is going to rotate without motor. Motor must be there to rotate the spindle. Then there is one motor, and that motor is spindle motor. That spindle motor is going to rotate, then spindle is also going to rotate. Yes, and the tool is fitted inside the spindle, then tool is also going to rotate. And the work table can move linearly, then the tool will come and it can do the machining. Tool will rotate and it can do the machining. Means tool is also going to move downward and upward, and this work table is also going to move linearly. Guys, to move in x-axis motor is there. To move in y-axis motor is there. To move in z-axis motor is there. 3 axes, 3 motors. And that concept is not explained in number of reference book also. 3 axes, 3 motors. Spindle has some separate motor, that is the spindle motor is there. And here the work table is going to move. The workpiece is clamped with the work table. Then as the work table is going to move, this workpiece is also going to move linearly, and the tool will come and tool will perform the machining operation. Yes, this is very easy topic. Here I tried to explain in a short span, and this is very important topic to prepare for your exam from the advanced machining methods. Then how many topics are there in advanced machining methods? The NC machines are there, CNC machines are there, and the numericals are available on the BLU, that is a basic length unit. How to calculate that basic length unit? By using this diagram we can calculate, and that BLU numericals are very important. Next, numericals on G codes and M codes. In one program we can use both G codes as well as M codes we can use. Then here there is a possibility of simple numerical. Then on the BLU also very simple numericals are there. G codes, M code is hardly one line program. Your degree programs are very big. Some student completed diploma, that programs are also very big in your diploma exam. But here the programs are very simple as compared to degree as well as diploma. Then here also the numericals are important. The next topic, guys, you can see the transformations. Transformations. Some new topic is there. From last 10 years they are asking the question on the transformations. Then there are also some numericals are available. Then out of that, any one numerical they can ask. With the some theory also can ask, and most possibility on about the two topic, that is NC, CNC, G codes, M codes, some theory question, 1 mark theory question, or in the match the pair format they can also ask the G codes as well as M codes for the mechanical. And for the PI, definitely numerical is also there, theory is also there, 3 marks, very small topic, and 3 marks, sometime it may be the 4 marks weightage for PI people, but for mechanical 1 to 2 mark weightage is there. Yes, now see our next, that is non-traditional machining methods here. Then guys, just say in the mechanical, just they made one big joke. What they written? The principles of non-traditional machining process, and only abrasive machining process they written. Which are the abrasive machining process? Abrasive machining. Abrasive is going to work, that is ultrasonic machining method, USM. Water jet machining method, abrasive water jet machining, or abrasive water jet machining, or abrasive jet machining. Here I need to remove water jet machining method, because in the water jet machining method we are not going to use the abrasives, but in the ultrasonic machining method we are using abrasives. In abrasive water jet machining, means water jet machining but add the abrasive. In only simple water jet machining we are not adding abrasive. And here the abrasive jet machining means abrasives plus here only they mention this syllabus. But the non-traditional machining process, that word they are going to use, and that word is very big word is there, very big word. And that big word you can see in the PI syllabus. The principles and applications of USM ultrasonic machining method, abrasive jet machining method, water jet machining method, abrasive water jet machining method, EDM, wire EDM, LBM, EBM, plasma arc machining, chemical machining, ECM, effect of process parameter on material removal rate. Guys, theory question is useful, and nowadays for the GATE exam, very simple question they are not asking on this chapter, but you can see that this effect of process parameter on material removal rate, how the MRR is going to happen in every method, how the material removal rate is going to happen in every method, that they are going to ask. And material removal rate is directly proportional to which parameter, that they are going to ask. Either it is ultrasonic machining method, water jet machining method, EDM method, electrochemical machining method. On all that method, the MRR is proportional to directly inverse. Sometime MRR is going to increase with some parameter is increasing, but after some time the MRR is going to decrease, and that question is very important. That's why all MRR you need to study in detail. I taught in the class in detail, and that you have to revise. And there is full 1 mark theory question possibilities here. Numerical also they can ask, but more theory possibilities there. And this topic is very important for state level exams. Number of questions they are going to ask. I don't know why they are going to ask, but number of theory questions they are going to ask, guys, on this chapter. And just see, out of all that method, which method has maximum material removal rate, highest material removal rate? ECM. Just ECM, guys. The theory is also there, and number of numericals is also there. And till now in the GATE exam, the maximum question is asked on ECM only. After then, the material removal rate, second largest material removal rate is for EDM method. And the second number of questions in the GATE exam asked on EDM. Third maximum question they asked on ultrasonic machining method. This ultrasonic machining method has third highest material removal rate. And after then, material removal rate started reducing. Water jet machining, ABM, and laser beam machining has the lowest material removal rate. Then here what is important here, guys? 1 mark theory question is more important, and some numericals are also available on ECM and EDM. The small formulas are there, just you remember that formula. Okay, sometime they can ask the numerical also, and numerical from last 10 years they are going to ask, or 15 years, last 15 years they started asking more numericals, but still there is more weightage for theory. Yes, now see the new topic. Additive manufacturing, introduced in the GATE exam 2021. This is one of the newest topic, new research in the world, and for the mechanical engineering GATE paper also, there is only one this topic, additive manufacturing, which is not an older topic. First patent is in France in 1984, and now still the research is going on. And for the mechanical you can see additive manufacturing, and for the PI additive manufacturing techniques. GATE 21 they didn't ask question for mechanical as well as PI, but GATE 22, 23 they asked question on additive manufacturing. You know, guys, what I said that in the class? I said that in the class, this is new topic, research is going on, the theory is available. Hence, you prepare theory of this topic, and that theory only asked in GATE 22 for mechanical and PI. For mechanical set 1 also, set 2 also, and for PI also they asked theory question. Again I said that only prepare theory, but in the GATE 23 they asked one numerical for 2 marks. Now what to do? I didn't cover the numerical in the class, but they asked the 2 mark numerical. But guys, numericals are not available in many reference books, but still they again the numerical. Then how to solve this type of numerical if I am not taking? Just see, very simple concept they are going to ask in numerical, very simple concept. Whatever you learn in the mechanical engineering, on that formula also they are asking the very simple numerical. There is no special preparation is required for that numerical. Just I will tell you, they asked one numerical to calculate time to complete manufacturing. And what is the formula for time? They given the volume. One component was there, big component. They given the volume, means some dimension of volume they given, and area also they given. Into area into velocity. Area into velocity is what? Flow rate, na? That they given. Means no special preparation is required for additive manufacturing. Simple, just see what is the unit of volume? Millimeter cube. Area is millimeter square. Velocity is millimeter per second. Then I am writing here millimeter cube per second. Then millimeter cube is going to cancel. What is remaining here? Seconds is remaining. Guys, no one think that they will ask numerical on additive manufacturing, but in the next exam also they can ask the numerical, but numerical no special attention is required. Only solve this numerical, very simple numerical they are going to ask. Volume is also given, volume is that component dimension is given, area is also mentioned, velocity is also mentioned, and they said that the calculate time. That very simple type of question they can ask on the additive manufacturing, no need to worry that. Some different question also they can ask, but apply your knowledge. Whatever you learn in your preparation of GATE exam, apply that knowledge easily, you can solve that numerical, okay? Now if you have any query, then you can ask me about the preparation. Yes, guys, thank you very much for attending this session, but I am going to read your message. If you have any query, then you can ask me here. I'm going to wait for some time here. Yes, in the session some students are asked that question and I cleared that. Here also, if you don't have any contact number, then here also you can ask me. After then, here in the video, you can send me a message, I will reply you. Okay, how to prepare short notes? How to prepare short notes? I want to say the formula notes, guys, formula notes. Formula notes. Now see here, in the casting topic I said that number of formulas are written here. Write down all formulas. Then Pn is what? Permeability. Write down first formula Pn VH by PAT. Pn is permeability number, V is volume. Write down unit centimeter cube. Height is height of specimen. P is the pressure. It is given in the exam. If not given, then we have to use 10 gram per centimeter square. Area is area of specimen, that is a cross-sectional area of specimen, and the time, here we are using the time in minutes, not in second. Here we are using the time in minutes, not in second. That all you have to write it here. Then you make the formula notes. But now it is very late, but yes, we have the time to make the formula note. Then you study one chapter nicely. After studying that chapter, solve that classroom practice question, previous year GATE questions, and then write down that all formula. And with that formula, write down that parameters also. What is V, what is H? Today you know that because you studied that chapter. But after 1-2 months, you may forgot. Then you need to write that parameter. Next, PT, what is that? Powering time. Volume, what is volume? Volume of casting cavity or volume of casted component. Then area, it is the area of sprue runner or ingate. Velocity is in root 2gh, height may be the height of sprue or total height, that you need to write down. And in that way, you make the formula notes for every chapter. First study that total chapter and then write down the formulas. In 1 to 2 pages, you can complete the 1 chapter formula. The same procedure you can apply for welding also. Welding in only make the formula notes now. Huh? Don't go for that short notes, because in the some theory also you can write in formula notes. But try to avoid write the number of theory points for the GATE exam. Huh? If you are preparing for other state level exam where the theory is more, then you can, in the short notes you can make and you can write the theory. But for the GATE, you need to make the formula notes. Here is also arc welding formulas are there. Write down that all formulas, resistance welding formulas. And here in advanced machining method, here is one procedure. If there is a 200 pulses are given, then there is a 1 rotation of motor shaft, then there is a gear ratio into 1 rotation of lead screw. That point you need to write down. Okay, and you make the formula notes. Okay, understood? Okay guys, thank you very much for attending this session, and all the best for your preparation as well as all the best for your exam. Again, thank you very much, all the best.